Welcome to SwageLock. I'm your host, Craig Gifford, and we're here today with Chuck Hayes, who's SwageLock's Global Technical Lead for Clean Energy. And we're talking about natural gas. And so, Chuck, let's just start the conversation with what are the different types of natural gas and why are there different forms of it?
Sure. So natural gas in its basic format is always methane. So that's CH4. So one carbon, four hydrogens make up natural gas.
Okay.
But we deal with it in different ways. We give it different names. So you can have it coming to your home through pipelines and used for your furnace and your hot water tank and your stove. It's used like that around the world.
Okay.
But there's also other forms. So other forms can include compressed natural gas.
Okay.
We call it CNG. Now the thing about that is that we compress it because we want to get more molecules on however we're transporting it or however we're using it. So we get more molecules in by increasing the pressure. The pressure we do it to is 3,600 psi, which is approximately 200, and that's about 249 bar.
Okay.
And 1 bar is equivalent to 1 atmosphere.
Yep.
So that's how much gas will be in 1 atmosphere.
Okay.
So you're getting about 250 times compression. We have another form, which is called LNG, for liquid natural gas. And that's when we're going to move a lot of stuff a long distance.
Okay.
We liquefy it and then move it as a liquid.
Okay.
So liquid you can't pressurize, you cannot compress a liquid, but you can get a lot more molecules in. So that's about 600 bar, so 600 atmospheres. So if you were to open it up, it would take up the room of 600 kilograms of area that it would for other gases. So the last one we have is renewable natural gas. And renewable natural gas is kind of newer in the world. It's got different names. It's RNG, often talked about in North America. They talk about it as biogas in some places.
Okay.
And basically it comes from waste streams.
Okay.
And it's fundamentally you take anything off of a waste stream, whether that be animal pens or biodigesters, which we use to be able to take farm waste and break it down.
Okay.
And basically the things of it is it smells. And so we have to get rid of the smell, so that's sulfur, get rid of that.
Yep.
Or we get rid of siloxane and a few other things. And you can end up with either a raw biogas that still has some things we call NOx and SOx. So NO, nitrogen and oxygen, X is for different amounts of oxygen.
Yep.
And SOx, NOx and SOx we call them. We knock those out, dry it down, pressurize it, and then we can put it through a system and use it just as that gas. So that's just a biogas. Then you can take it one step further, knock everything out of it, and get it right down to CH4, and you have natural gas again.
So, Chuck, what are the different types of distribution and refueling infrastructure for natural gas? And what are some of the challenges associated with that?
Sure. So to start off talking about refueling infrastructure, we're talking about trucks or cars right now, and possibly ships. So the differences really are, CNG and RNG are actually the same thing.
Okay.
In chemical form, they're both CH4, they're in gaseous form, and they're pressurized.
Okay.
So we use those to fill up trucks and or big trucks, small trucks, delivery trucks, buses, and they're off. The way it's done is it's done at fueling stations, like on the side of the road, on a truck stop for long distance use, or more often than not behind the wall.
Okay.
So companies will have their own fleet of vehicles, and you'll see a lot of these. So you have that station at your own facility. And in those, what they do is they literally have a big header line, and they'll line all the trucks up in a row, and they'll bring a hose down and connect it, and turn on the hose and turn on the vehicle, and let it slowly fill up overnight.
Okay.
So you can fill every day. Well, that doesn't work if you're going cross country. Right. So cross country, you're going to be on the back side of the truck stop, on the other side of where the autos are, and you're going to come in and hook up what looks like a regular pump.
Okay.
A little bit different way it connects, but it locks in place, and you fill that way.
That's much more of a fast fill.
It's very much a fast fill station. So it's there to fill up that truck in 10 to 20 minutes.
Okay.
And then the other thing is like LNG. So LNG is liquid, but it's really cold.
Yeah.
So that cold can be dangerous. You can actually get burns from the cold.
Okay.
And special types of clamping on mechanisms that are used. You have to have special PPE or personal protective equipment to be able to use it, and more training. So sometimes operators load those themselves. Sometimes they actually have somebody at the station that's trained that will do it. And then the last real place we do it is on ships. And we either have it as ships as an alternative fuel. So very many places in the world no longer allow you to bring heavy fuel oil into ports in littoral waters.
Yep.
So they get close and they switch to LNG, which is actually then gasified and used as CNG on the truck or on the boat anyway. But then the other thing is for big transport. So we've got these large tankers that are going to go over the seas to deliver CNG or LNG to other places. And the challenges are really compression. We have to compress it for compressed natural gas. You have to keep it safe, so tanks and containers to keep it safe, and then the right components. And having the right components that are leak-free are really important. And Then in LNG, it's the temperatures and so forth as well, and those are the pumps.
What are the pertinent LNG and CNG standards that designers need to be aware of?
That's a great question. And it's a little bit different answer depending on where you're at in the world.
Okay.
So we'll start with CNG. If we're talking about on vehicle, in North America, CSA, or the Canadian Standards Association, is responsible for all those standards. And those standards are in place for safety. That's the main reason they're there. So there's NGV standards, so natural gas vehicles, and anything that starts with a 3, so NGV 3.1 and so forth, are for on-vehicle components.
Okay.
And there's a number of those different ones. That'll tell you how to spec those components, how those components have to be tested to be able to be compliant for being used there. In LNG, we've got LNG standards as well. It starts the same way. 3 is the first number for on-vehicle. In Europe, it's a little bit different. We have ECR 110, which is the on-vehicle standard.
Okay.
Different certifications needed for that. They're very, very similar in the testing because we work really hard across the standards groups to harmonize those over the different continents. But then when you get to stations, it's same thing. It'll be NGV, but it'll be a series of 4 point whatever, to be able to put together, and that'll tell you what you need for the components for the station.
So there's a lot of different things across the spectrum, depending on what you're doing, where you're doing it, and how.
Yeah, and then even so, like in India, where they do a lot of CNG, they're basing their standards off of the international, the ISO standards, but they put their own little flavor onto it, and every country can do that, and we all do it for different standards.
Okay, great.
Yeah.
So Chuck, tell us, what are some key considerations for safety when it comes to CNG and LNG storage?
Sure. So let's start at the very basics. So CNG as a gas is designed to be used and burned, or go into a combustion chamber. So therefore, it's actually little explosions. So the gas is explosive. It's flammable, and we want to make sure that it doesn't get out.
Right.
So it doesn't get out any place in the world. So when we're dealing with just CNG in the gaseous form, we don't actually use LNG in the liquid form. We store it in the liquid form and then transfer it back to a gas to use it.
Correct.
So that's an important piece to remember. But in either case, we want to keep that gas in. So by keeping that gas in, we have to have high quality products following the standards and products that have been approved by the standards to be able to be used within that application. So low leak rates, good valves, great fittings, so forth. Those are things Swagelok can help with. A good design helps as well. But in LNG, there's one extra point of it, which is we do have that problem that gas is very, very cold. So that cold, you can get cold burns and freezing of lungs and a lot of other things if it expands. If it expands very quickly and is released completely at a 600 to 1 rate of expansion, that can be a very powerful release of energy. So keeping them all safe, no leaks, no releases unintentionally into the atmosphere, and that's how you keep it safe.
Well, thank you for sharing your knowledge with us, Chuck, and thank you for joining us at Ask Swagelok.